Hello, Professor. My name is Corbin Garver, and this is going to be my final exam. I hope you can hear me all right. I'm also kind of at a weird angle, laying in my bed in my dorm because I just had knee surgery, so hopefully it's not too big of a deal, but I'm stuck in my bed for a few weeks. The first question, calculate the change in Trump vote percentage from 2016 to 2020 for each county. Um, I did over here. First, I made a new category, change in vote, by obviously by just doing this category minus this category to give us the change. Obviously, you can see there was way less votes for Trump in 2020, or at least in Colorado. I mean, obviously in the whole country too, because he lost. But yeah, and then a few counties had a little bit of change, and then I guess one, maybe two had a lot of change towards Trump. But yeah, number two. Here's just my scatter plot here for number two. I just took the two categories that you said and threw it into the scatter plot. Not a lot of correlation there, at least it looks like to me. And then number three is down here. I put the trend line in there as well, and then I got the equation up here for the trend line, negative 1.35 times x plus 86.1, which is the slope, and then I got my r squared for the trend line as well up here, 0.548. Oh geez, hit the wrong button. Oh, sorry about that. And then, oh yeah, the equation. Obviously, I just let Excel do the work for me, but I threw 35 in the slope. The equation for the trend line. Sorry, the equation for the trend line. I threw 35 in there for x, and I got 38.85%. And then, number seven. I'll just do seven, 8, and 9 all together here, so I started out by just doing countif function to count all the sixes in every single roll probability, and then for one or more sixes, I did if E2 equals 1, then give me a 1, or if it doesn't, give me a 0. And then for the occurrences, I did the sum, giving me the probability right there for one or more sixes, which seems low in this instance. I can't get him to re-roll right now for some reason, but other times I did it was way higher than this, but I guess we're on the low end right here. And then two or more sixes, same thing. I just had E2 if it was greater than or equal to 2, 31 times for a probability of 3.1%. And then all three sixes didn't happen one time in this roll to 1,000, or out of 1,000 rolls right here. So giving you the probability of 0, even though it's not true, it's definitely higher than that. And if I did it a few times, I'm sure there would be at least one or two times that I got three sixes. I think that's 7, 8, and 9 there. Then number 10. Oh my gosh. Number 10 is my regression output equation. Here's my y-hat equation right here. I took the coefficients off of the regression summary, and then I labeled my variables here as well. And then my most significant, I thought was bachelor's degree or higher percentage, because the p-value is the lowest, obviously, and then the absolute t-stat is the highest out of all the variables. In absolute terms, it's the highest t-stat. And then unemployment percentage, I thought was the least significant, has the highest p-value, lowest absolute t-stat, so that'd make it the least significant. And then for question 13 and 14, yeah, they're right there. I obviously just plugged in the given variables into the y-hat equation, let Excel do the work for me, and it spit out 64.5755% and 65.5985% for question 13 and then question 14. Right there. And then for 15, yeah, I took my previous, I kind of redid a little bit of it, but this is what I had done the first time for my stock market simulation. I put the, I'm gonna drag that out. I put the total beginning balance up here, and then I split it. I left it 60-40 like we had previously done. So 60% went to the stocks, 40% to the bonds. And then I ran a 40-year simulation just like before. For my, I obviously, and then I made a bonds balance and a stocks balance, and then I added up for the total balance. And then I ran the sim. I'm going to run it again. Obviously, and then I made these extra two categories to calculate the probability over 1.2 million. It obviously changes every time you run the script, but I did the COUNTIF function, counting how many times in this group of 40 there's an answer over 1.2 mil, and then I obviously did the probability of that out of 40 times. So this certain script I ran, 47.5% chance that if you started with 12,000 and contributed 2,000 annually, 1,000 to the bonds and 1,000 to the stocks, there's a 47.5% chance that you have over 1.2 million with our simulation. Yeah, other than that, I think that's all I got. I guess I'll say thank you for a great semester, and yeah, I actually learned a lot about Excel and spreadsheets, and it was a good time, so thank you.